So for question 4, what we're going to do now is we're actually going to kind of convert this graph using what we call a standardized score. This is also known as a z-score. And what this does, the whole kind of purpose of this, is it takes our graph and it kind of shrinks it down, it kind of scales it down to where the mean is at 0. And then that way all of my standard deviations are just at -1, 1, 2, and 3 accordingly. And so what that does, a standardized graph, standardized normal distribution, allows us to compare graphs that are normally not the same, right? We have this graph here up at the top where my mean is 80 miles an hour. We can see that the standard deviation was 7.7, and that's a very specific case. But if I wanted to compare that to another graph, it would be hard because they might not have the same average miles per hour. They might not have the same standard deviation. So how do we compare them? And that's using a standardized graph. And so we'll get into a little bit of that later. But to find a standardized score, what we're going to do is we're going to say z equals our current value minus the mean for our graph divided by the standard deviation. And so what that looks like for our problem would be z equals our value, 68.45, minus the mean, which was 80, divided by standard deviation was 7.7. So if we do this in a calculator, so I'm just going to use the basic calculator on the right. So we have, I'm going to put parentheses, 68.45 minus 80, close the parentheses, divided by 7.7. So you see our fraction looks basically the same as it does on our notability, but it just has the parentheses on top, which is fine. And I'm just going to hit execute, and it tells me that is -1.5. And so what this score represents, it says that 68.45, right, that we labeled right here, in between, about halfway in between -2 and -1, if we recentered our graph around 0, would be right here at -1.5. Okay, that's the part we're looking at here. And so again, what this also means, right, it's the number of standard deviations away from the mean. So it's -1.5 right to the left, 1.5 standard deviations away from the mean. So how do we use this, right? What do we do with this information? So we're going to go into our distributions app. So we're going to go down to distributions, click OK. We're going to go down to normal, because we're working with a normal distribution. And this time I get to just leave the mean and standard deviation alone, okay? Because we've now reset to this graph right here, where our mean is at 0 and our standard deviation is 1. Okay, this would be, if we wanted to label this, right, we'd say that this is the normal graph from 0, mean 0, and standard deviation 1. So we're going to leave those two alone. We're actually going to go just down to next. And now I want everything less than, right, my direction said less than 68.45. So now we're going to use this new z-score though. So I want everything less than, so to the left, which again, our highlights here on the left is already good to go. Everything less than -1.5, click execute, and it tells me that my probability of x being less than or equal to -1.5 is 0.001. 0.0668, which is 6.68%. And that is a little bit less than what we found earlier, right? When we were just estimating it to be 50%, right? If that was the true halfway point, it would have been 9%. But when we kind of talked at the end of the last video that this purple section looked a little bit smaller than the blue one, right? Even though it's the halfway point, the area is a little bit smaller. It makes sense that our percentage is actually a little bit smaller. And so we can use z-scores to find those percentages for values that aren't specifically +1 standard deviation, +2 standard deviation, 3 standard deviations, -1, right? When they're not right on those lines, and we can still do it with those lines, but when they're not on the lines, we have a method of actually finding a more accurate answer here. Okay, so we're going to do a couple more examples of that here on the next page. So it tells me that the distribution of speed follows an approximately normal distribution with a mean of 80 and a standard deviation of 7.7. So what percent will give the DeLorean a speed less than 68.45? So again, if I want to kind of think about this on my graph, okay, we're just going to draw a quick sketch. Say there's my normal distribution. My mean is at 80. And where is 68.45? Oh, it's over here somewhere. All right, so somewhere over there, and it's everything to the left of that. And so if I want to turn this into a standardized graph, where my mean is at 0, I'm going to try to find that same spot. And so that is my z-score, right? That question mark right there is what I'm trying to find. Like if I can find it, then I can pretty quickly put that into a calculator. So for this particular problem, we're going to find our z-score. So z equals our value minus mean over standard deviation. So 68.45 minus 80 divided by 7.7, which is -1.5. We just actually did all that work on the last problem. And so again, if we go into my calculator, the probability of x being less than or equal to -1.5 was 0.0668, which is 6.68%. Okay. So that was question 5. Question 6. What percent of the runs will give the DeLorean a speed greater than 85? So again, greater than 85, greater meaning to the right. So if I think about my graph, here's my distribution. Our mean's at 80. 85 would be here-ish. I don't really know exactly, but we'll say it's there. And I want everything to the right. So again, how are we going to find that? We need to convert that to a standardized graph, our mean at 0. And we need to figure out, okay, well, what is that value there? So I need to figure out my z-score. Z equals value minus mean over standard deviation. So 85 minus 80 over 7.7. In this case, I don't know what that is off the top of my head, so we're going to go back to our calculator, hit the home button, go up to calculation. And I'm just going to copy this text up here since we have it already. So Shift copy, Shift paste. And I'm just going to go up and edit this first number here. Type in 85. So that gives us a z-score of 0.0668. So go ahead and round that. 649, so you can use 649, you can use 65, either one. And so again, in this case, we want greater than right to the right. So when I go back to my distribution, let's go back to distributions. I want to pick to the right, and now I want 0.65. So it tells me that the proportion x being greater than or equal to 0.65 is 0.2578, which is 25.78%. Okay, so if you want to try number 7, you can go ahead and pause the video for a minute and see if you can figure out number 7 on your own. I'll pause for a couple of seconds before I start, but see if you can give it a try. Again, recognize we're now doing the between, so we're going to have to make sure we also fix that on our calculator. Okay, so if you want to try it on your own, pause it for a couple minutes, try it, and then come back and finish the video. So for number 7, we want between 70 and 95. So again, if we draw our normal graph here, we have our means at 80. So 70 would be, I don't know, somewhere here-ish. And 95 would be here-ish. And so we want everything in between. So all of that stuff in there. So again, kind of what we're going to have to do is figure out where would that be on our standardized graph. Our standardized graph would be at 0. I don't know what this left edge would be. I don't know what this right edge would be. But I know if I can, it's pretty easy to find the middle percentage. Okay, so we're going to have to find 2 z-scores on this problem. So our first z-score, value minus mean over standard deviation, it's going to be 70 minus 80 over 7.7. Again, I'm going to go back to the calculator. Go ahead and paste that in again, and we'll use 70. Oops. If I do that this time, I get a negative number, so negative 1. We'll do negative 1.30. We'll round that up. 298 would round up to 0.30. And if we do the other z-score, value minus mean over standard deviation is 95 minus 80 over 7.7. So again, whoops. Go ahead and paste that in. 95, 1.95. So it tells me that my 2 z-scores are negative 1.30 and 1.95. So if I go to my distribution on my calculator, oops. Again, I want the between, so we're going to pick the middle graph here in between. We want in between negative 1.30. To the right, we want 1.95. So the probability of negative 1.3 being less than or equal to x, less than or equal to 1.95. And again, I'm just writing that statement that's in the calculator there, the capital P parentheses, and then our 2 numbers with x sandwiched between them, equals 0.8776 or 87.76%. Okay. So again, we can use the standardized score, the z-score, to help us figure that out. Okay, it's really nice when we have numbers that are not just 1 standard deviation or exactly 2 standard deviations. It allows us to find and be more flexible with any number within our data set. Okay, so to kind of wrap that up, a couple of notes here. So we have learning targets number 1, 2, and 3. So we had area to the left, area to the right, and the area between. So if we think about this in terms of our normal graphs, I'm actually going to lower these down a little bit here. Give ourselves some more space. So we're going to have 3 normal graphs. You can just do this once and copy and paste it if you want. Oops, I'm going to fix that last one. Dang it. Sorry, guys. Close enough. And so again, right, all of these have a mean of 0, right? The whole goal is to standardize them, create a mean of 0, and then find our z values. So to the left, right, can find any z wherever it is, and we just want the area to the left. And so how we do that is we do the proportion of x less than or equal to our z-score equals the area, right, the percentage. For the right, again, I'm just going to go to the right just to make it visually look a little easier to understand. We want P, and I just want to double check and make sure I write this down right. So if we go to our numworks, okay, so it does keep x first. So x has to be greater than or equal to our z-score. And that is our area, our percentage. It gives it to us as a decimal, so we still have to convert it, but I think you guys get the picture. And then lastly, the area between. So we have z-score number 1, we have z-score number 2, and we're trying to find everything in between there. So when that happens, we do the probability of z-score 1 less than or equal to x less than or equal to z-score number 2. So z1, z2, and again, that gives us our area, our percentage. Okay. So again, this is why I really like these numworks calculators. So please get used to them, either using your iPad, using the actual calculators in class, because this kind of stuff, being able to change to the left side of the graph, between, to the right, makes this really easy, really simple and straightforward. I really like too that on the graph, it gives us that shading. It actually changes the shading so you guys can see and make sure that it matches what you guys are trying to accomplish. Okay, so just keep that in mind as you're working through these. Okay, so if you have any questions, let me know, but that's basically it. Again, kind of the big idea here, z-scores. Okay, your standardized scores, finding your z-scores, and then using your calculator to figure out that area percentage. So if you have questions, let me know. Otherwise, I hope you guys have a great day, and I'll see you guys soon.